Now let's see the next question. W is equal to phi plus I psi represents complex potential of an electric field. If psi is equal to a form given to us, and we need to find out what is the corresponding phi, so that this represents the complex potential of an electric field. So in these cases we have already seen in the theory lectures, W represents the complex potential of electric field, then phi and psi, the whole W shall be analytic function, so that phi and psi shall satisfy the CR equations. What are the CR equations? Dou phi by dou x is equal to dou psi by dou y. And the second equation is dou phi by dou y is equal to negative of dou psi by dou x. These are the CR equations. Now psi has been given to us, we need to find out phi. This can be done in two ways. One is by the theoretical knowledge, since dou phi by dou x is equal to dou psi by dou y. So if you write this as, you can write this as dou phi is equal to dou psi by dou y dx. So integrate both the sides only with respect to x. Then on the left side you can get phi. On the right side psi has been given to us. Now what will be dou psi by dou y? Integral of, with respect to y, if you do dou psi by dou y with respect to y, this whole thing you need to differentiate with respect to y here. So with respect to y, if you differentiate, x square is a constant term since it is partial differentiation, so this will not be there. Here it will be minus 2y. So this term I am partially differentiating with respect to y here. Okay, dou by dou y of this whole thing I am doing. So with respect to y, if you do this again, it becomes x is a constant into, this is 1 by x square plus y square form, or rather y2. To eliminate any confusion, I will just write it completely. So dou by dou y of, what is psi? X square minus y square plus x by x square plus y square dx. Now integral of, what is dou by dou y of x square? 0. Since it is partial derivation, x would be treated constant. What is dou by dou y of minus y square? Minus 2y. It is dou by dou x of y power n formula. So y power n is n into y power n minus 1. So y square is 2 into y power 1. So 2y plus partial differentiation with respect to y, so x can be treated constant, so that can be taken out, into dou by dou y of 1 by x square plus y square. What is the differentiation of 1 by x square plus y square? What is the it is of the form 1 by f of x. What is the differentiation of 1 by f of x? That will be minus 1 by f of x square into f dash of x. Chain rule. Okay, d by dx of 1 by x is 1 minus 1 by x square. So 1 by f of x will be minus 1 by f of x square into f dash of x. The same way if you do it here, it becomes x into minus 1 by x square plus y square whole square into f dash of x. Here f of x is x square plus y square. With respect to y you do it. It becomes into 2y because x square is constant into 2y. This x square plus y square alone you need to differentiate with respect to y again. If you differentiate, x square is constant 0, y square is 2y. So this whole thing into dx. Now if you do this again, here what you need to do? This you have to integrate with respect to 2x, treating y as constant. So now, if you treat this y as constant, this whole thing is constant. So you can take it out. So minus 2y into, here nothing will be there, minus 2y into dx. Integral dx is x. So this becomes minus 2y into x plus, with respect to x you are doing, so all y terms will be constant. So 2y will come out, minus 2y. Minus 2y into, what I am left with here is Okay, I'll do just one thing here. Y I'll take out constant, just plus y I'll take out. The remaining things I'll write it here. Minus 2x by x square plus y square whole square. Okay. This is this integration I have already done. This is integral of this into dx. Okay. Now, okay, y is, let us say y is out of the integration, so y into I will write this one. Now, what is the integration of this? Integration of minus 2x by x square plus y square whole square. If you recollect, what will be the derivation of 1 by x square plus y square? Dou by dou x of. Using this formula, what will be its derivation? Minus 1 by x square plus y square whole square into derivation of this with respect to x, that is 2x. So, minus 2x by x square plus y square whole square is nothing but partial differentiation of 1 by x square plus y square. So, this expression is same as this. So, this I can write it as dou by dou x of 1 by x square plus y square. So, if you integrate on both the sides, integration of this expression is nothing but 1 by x square plus y square. So, the same thing I will write it here. So, it becomes, so this becomes minus 2xy plus y into 1 by x square plus y square plus integration constant c. So now you see which is the option satisfying the equating this minus 2x equal to this minus 2xy plus y into 1 by x square plus y square. So option A is the correct answer. However, this we have solved using the theory what we know about using the CR equations. Now, in addition to this, what we can do in case of particularly for the CR equations, or particularly when you have to find out phi has been given, psi you need to find out, or psi was given, phi you need to find out. What you can do is, you already have CR equations with you. And you already have psi with you, psi has been given to you. You just you just substitute psi here and substitute all the options here. First you substitute A and then you substitute B, then you substitute C likewise. By substitution also, you can just check which option actually satisfying the CR equations. By substitution if we do, how we can find out the answer, let us see. For example, option A you take. Okay, given psi, first calculate dou psi by dou y. What is dou psi by dou y? With respect to y, if you do, it becomes minus 2y, we have already done this, plus with respect to y, if you do, it becomes minus 2y, here we have done x into this one, minus 2xy by x square plus y square whole square, minus 2xy by x square plus y square whole square. Similarly, dou psi by dou x you find out. With respect to x, if you do, this becomes 2x. Okay, this is 0 plus this is x by x square plus y square. Let us write it as x into 1 by x square plus y square. Plus, I am writing this as x into 1 by x square plus y square. It is in the form of uv. So, u dv plus du into v. So, differentiation of x first, that will give me 1 into 1 by x square plus y square plus x into differentiation of this with respect to x will be minus 2x by x square plus y square whole square. Okay, now if you rewrite this 2x plus 2x plus 1 by x square plus y square plus minus 2x square by x square plus y square whole square, sorry. If you simplify this, it becomes 2x this x square plus y square by x square plus y square whole square it becomes. So x square plus y square minus 2x square, that is y square minus x square by x square plus y square whole square. This is a simplification I am just writing by adding these two. Okay, so what is dou psi by dou x? 2x plus y square minus x square by x square plus y square whole square. Now I'll just erase this formula and this area. Okay, now consider each phi and find out dou phi by dou x and dou phi by dou y, and check which dou phi by dou y for which option the CR equations are satisfied. Now consider option A. Now find out what is dou phi by dou x. With respect to x, if you do, this is minus 2y, plus with respect to x, if you do, y is constant, so y into minus, with respect to x, if you do, y into minus 2x by, I am directly writing it here, we have already seen it, so it becomes square 0. So dou phi by dou x shall be equal to dou psi by dou y. So both are same. If you see, minus 2y minus y into 2x minus 2xy by x square plus y square whole square. So first CR equation got satisfied. Now go to the second. Now find out what is dou phi by dou y. With respect to y, if you do, here you will be left with minus 2x. Here let us write it as same UV form, y into this formula, y into 1 by x square plus y square. So differentiation of y, first 1 into 1 by x square plus y square, then differentiation y into differentiation of this with respect to y will give me minus 2y by x square plus y square whole square. If you simplify this, minus 2x plus this is again x square plus y square minus 2y square, that is x square minus y square by x square plus y square whole square. So if we compare dou phi by dou y and dou psi by dou x, if you see, this is minus 2x plus x square minus y square by whole square, and this is 2x plus, instead of x square minus y square, here y square minus x square is there. This is nothing but negative of this. So dou phi by dou y is equal to minus of dou psi by dou x. So second equation also got satisfied. So our correct option is option A. So while solving any analytical function related or CR equation related equations, if you want to find out psi, given psi, if you need to find out phi, or given phi, if you need to find out psi, two ways you can do. One is by using the CR equations, directly integrate the equations for required function, or check which of the given option satisfies the CR equations. One of the method you can do. Let's see the next question now. The residue of f of z is equal to z cube by z minus 1 power 4 into z minus 2 into z minus 3 at z is equal to 3. So this is a residue problem. So we already know by observing the given f of z function, at z is equal to 1 we have a fourth order pole, at z is equal to 2 and z is equal to 3 we have simple pole. So what is asked is, at z is equal to 3 what is the residue? What is the formula for a residue in case of a simple pole? In case of a simple pole, what is the residue? Residue of f of z, that is equal to limit z tends to a, or suppose if it is simple pole at z is equal to a, then limit z tends to a, z minus a into f of z. This is the formula. Here what is a? Z is equal to 3. Just substitute that. So this becomes limit z tends to 3, z minus 3 into f of z is z cube by z minus 1 power 4 z minus 2 into z minus 3. Okay, so if we substitute, this becomes limit z minus 3, or otherwise z minus 3 gets cancels. We are left with z cube by z minus 1 power 4 into z minus 2. Directly substitute this value. It becomes 3 cube, that is 27, by 3 minus 1 is 2 power 4. 3 minus 1 is 2, 2 power 4 is 16. 3 minus 2 is 1. So the answer is 27 by 16. This is from direct formula, so the option D is the correct option. So in general, whenever the residues are asked, if the residue at which it is asked is of a simple pole, like in this case z is equal to 2 or z is equal to 3, directly what you can do is that simply erase that, don't consider that particular term, and substitute the z value in the remaining terms, and that should give you the answer. That works in case of a simple pole. If it is pole of higher orders, then we need to use the formula what we have. Okay, now let's see the next question. The value of the integral 0 to 2 pi 3 by 9 plus sine square theta d theta is. Options were given. Remember, whenever this kind of a formulas are given, this kind of integrations we need to find out. In my lectures, I have already given you a set of differentiation and integration formulas. You try to find out to which formula directly we can actually, slightly the given function, to which formula it exactly resembles. If you recollect, differentiation of tan inverse x, d by dx of tan inverse x. What is the differentiation of tan inverse x? 1 by 1 plus x square. So the moment it is of this form, 3 by 9 plus sine square theta d theta, then I can somehow relate this to this form. So if I can convert this into this form, 1 by 1 plus x square, so integration of this would be directly tan inverse x. So I can write it as tan inverse of something between 0 to 2 pi. So to do that, now I should convert this into 1 by 1 plus x square form. I have already 9 plus sine square theta form. Okay, now to convert it, I can directly divide it by 9 here in the denominator. I will get 1 plus sine theta by 3, sine square theta by 9, that is nothing but sine theta by 3 whole square. But the problem here is, if I assume that sine theta by 3 has some t, so dt will become cos theta by 3. That I should require here. dt is equal to cos theta by 3 d theta, but I don't have that. Okay, so to convert this, I cannot directly divide it by 9 and then assume something. So I need to do little more to convert this in this format. So what I will do here is that instead of directly dealing with sine thetas, I will transform this into, so that I'll transform slightly so that I can convert this into that form somewhat closely. So what I'm going to do here is integral 0 to 2 pi 3 by 9 plus sine square theta. So what I'll do is I'll divide both numerator and denominator by cos square theta. So this would give me 3 by cos square theta. What is 3 by cos square theta? 3 secant square theta by 9 by cos square theta plus sine square theta by cos square theta. 9 by cos square theta plus sine square theta by cos square theta d theta. So this is equal to integral 0 to 2 pi 3 secant square theta by 9 by cos square theta is again 9 secant square theta plus sine square theta by cos square theta is tan square theta d theta. We know relation between secant square theta and tan square theta. I can write secant square theta as secant square theta is equal to 1 plus tan square theta. So this becomes integral 0 to 2 pi 3 secant square theta by 9 into 1 plus tan square theta. That becomes 9. Okay, I'll write it. 9 into 1 plus tan square theta plus tan square theta d theta. Now further this becomes integral 0 to 2 pi 3 secant square theta d theta by 9 plus 9 tan square theta plus tan square theta, 10 tan square theta d theta. Okay, now I have approximately into this form, but why did I write tan square theta? Because if I assume tan theta to be some new variable t, then tan theta, differentiation of tan theta is secant square theta. So secant square theta d theta will be equal to dt. I have secant square theta d theta here. So this works, but I have 9 here. All I need to do is I should get 1 here, so that it becomes 1 plus some x square form. How will I get 1? You divide both numerator and denominator by 9. Okay, now how this will become? Integral 0 to 2 pi 3 by 9, that is 1 by 3 secant square theta d theta. So it becomes 1 by 3 secant square theta d theta by 1 plus 10 by 9 tan square theta. Okay, 1 plus 10 by 9 tan square theta. Now approximately this is in this form. So in place of x, now I have 10 by 9, in place of x square I have 10 by 9 tan square theta. So square root of this would be equal to x. So let me write the same thing. Assume x is equal to square root of this. So square root of entire thing I will write 10 by 9 tan square theta. Okay, for easy understanding I am writing, or otherwise we can directly take the square root. So it will be root 10 by 3 tan theta. Differentiating both the sides, so that d theta I need to convert into dx. So dx will be equal to root 10 by 3 tan theta is, differentiation of tan theta is secant square theta d theta. This we already know. So what is d by dx of tan theta? Secant square theta. Okay, the same thing I wrote here. Now substitute these things here. This becomes integral 0 to 2 pi. Would it be integral 0 to 2 pi? You need to think, because when theta is equal to 0, x is equal to root 10 by 3 tan 0. Limits also you need to change. When theta is equal to 0, x becomes tan 0 is 0. So x is 0. When theta is equal to 2 pi, x is equal to tan 2 pi. Tan 2 pi is what? Tan 2 pi is again 0. Correct, right? Yeah. Okay. So now at x is equal to 2 pi also this becomes 0. So our limits becomes 0 to 0. So would it be valid? If it is 0 to 0, you don't need to do any integration, that outrightly becomes 0, because whatever value you get, you have to substitute 0 minus you have to substitute 0. Equal value, so it becomes 0. So this is not valid. That means some mistake we are doing. What would be that mistake? The mistake is that if you observe the given function, it is actually even function in the given interval 0 to 2 pi. So this I can write it as integral 0 to 2 pi, the given function integral 0 to 2 pi, some f of x is there, d or f of theta d theta. Okay, now this since if it is even function between the given limits, I can write it as 2 into integral 0 to pi f of theta d theta. Again you check between 0 to pi whether it is even or not. It is still even. Between 0 to pi also it will be even, because I have sin theta here. The graph of sin theta will be something like this, na? 0 pi 2 pi 0 pi by 2 pi 2 pi. So between 0 to 2 pi, it is 2 same. the portion, I mean the area here and here will be same. Again 0 to pi also it will be same, not exactly even, but the function will be same. So between 0 to 2 pi I can write it as 2 into 0 to pi. Similarly 0 to pi I can write it as 2 into 0 to pi by 2, but there is no repeating pattern between 0 to pi by 2. So again this can be written, this particular thing can be written as 2 into 2, that is 4 into integral 0 to pi by 2 f of theta d theta. So 0 to, now the limit is pi by 2. The limit is pi by 2. At pi by 2 what happens? When theta is equal to pi by 2, this is tan pi by 2 is infinity. So the new limit becomes infinity. Okay, limits, variables you are changing, so limits also you are supposed to change. Now 4 into integral 0 to infinity secant square theta d theta is nothing but, what is secant square theta d theta? 1 by 3 into 3 by root 10 dx. Okay, I will write that dx by 1 plus 10 by 9 tan square theta is x square. This is the new form. So that will be 3 gets cancelled. So 4 by root 10 into, this one is into, what is integration of d 1 by 1 plus x square dx? From here tan inverse x. So it becomes tan inverse x between limits 0 to infinity. So that becomes 4 by root 10 into, what is tan inverse infinity? Pi by 2. Substituting the limits. What is tan inverse 0? 0. So this becomes 2 2's, so 2 pi by root 10. Okay, so the answer is 2 pi by root 10, option A. So there are two key things to remember here. One is to change the given integral. It is in between 0 to 2 pi. It can be written as, since it is an in the given function. The given function is what is a symmetric or even, we can name it as, in 0 to 2 pi we can write this as 2 into 0 to pi, and then again you can write it as 2 into 0 to pi by 2. So it becomes 4 into 0 to pi by 2, 4 into 0 to pi by 2, 3 by 9 plus sine square theta. You convert that by using cos square theta and then assume, you convert this into this particular form, 1 by 1 plus x square form, then you integrate it. This is the solution. As you keep practicing, you would be able to identify to which form it would actually resembles, and then what I should do to convert it into that form. I cannot directly take it by 9. If you do, I cannot assume sine theta is equal to t, because if you doing so, while doing the variables, changing the variables, you need some relation between d theta and the new variable, say suppose dx. To get that, you should be able to convert this into some kind of secant theta tan theta. That's what I have done here.